Hello, friends. Happy to spend a little bit of time with you. Wanted to make a video about how to do some of the homework related to selections. Let's share our screen. Let's go ahead and get started. All right. So I'm running in Spider. One of the things I should point out, I ended up needing to uh, do a new environment in Anaconda called Spider. The reason for that, um, if you're running in the base environment, it'll run 5.1.5 right now, and we were having some problems with that running an input. So I just went over to environments. I created a new environment that was clean, and I called it Spider. And then I could select 5.3.3. And then I had to install it and launch it, and that got me here. Okay, we're going to create a new file, and let's talk about which problem we're going to work through today. So we're in chapter 4, or at least that's what I'd like to work through. And so we'll start with this one. And so I'll go up here and I'll say File, Save As. Looks like I've got a cashier algorithm. So I'm just going to call this one Cashier Algorithm Video. But I'd like to see uh, what was done in the cashier algorithm. So I'll open that up. Cool. So we have a start, and that's not a bad start. The program description is still the same. I'm actually going to just kill this one off, and let's focus on this. Let's see if we can get this done. All right, so it says write a program. Now let's verify that it's the same one that we're looking at. Yeah, write a program with the total change amount as an input and output the change using the fewest coins, one coin type per line. The coin types are dollars, quarters, dimes, nickels, pennies. So if the input is 0, no change. If the example is 45, 1 quarter, and 2 dimes. Okay. Let's, you know what? I'm going to grab that because that's a little bit more information. Okay, so instead of doing this math, I'm going to tidy this up. I'll just say change do equals. I'm not going to do an input this time. I'm just going to hard code this. And so I'm going to say, for now, change do is 0. Okay. So down here, I'll change my variable name. So if change do is 0. And for now, I'm just going to get rid of these little ones here. Oops. Move that over. And since we're changing the variable name, I'll change it across the board. And let's just see if this first case works. That's all I'm really interested in. Now let's clean this up just a little bit. Okay, run that again. Okay, no change. All right. So I always like to give myself feedback. I use a formatted print statement, so that lets me do a substitution for a variable. So I'm going to say Run it. Change to back is 0, no change. Okay. All right, now let's start let's start working through this. Write a program with a total change amount as an integer input and output the change using the fewest coins, 1 coin type per line. The coin types are dollars, quarters, nickels, dimes, and pennies. Okay. So this is an example of a problem where we can use the cashier algorithm. So there are different problems that we can work, and we can work this a number of different ways. There are ways that are more efficient and less efficient. So let's test for 1, and change do is 1. So we'll run that. 1 penny. So 2 pennies. Cool. This only works if we get to a point where we've got less than 5 cents of change. We might be able to do this a little bit differently. I'm going to separate these blocks, and we're going to work through this kind of slowly and try to have a nicer code. So if change due is 1, 0, it should be no change. I'm just going to get rid of these because I feel distracted by them right now. So let's say that we want to deal with so if the change is due, should print no change. Else, we should have these different cases. So let's deal with change is more than $1 and change is less than $1. Okay. So what I'm thinking through here is we can do kind of a greedy algorithm. We're going to start at let's start change due is maybe $4. And so I'm going to say if, and then I'm going to say $1, so 100 pennies, is less than or equal to change due. Now, I'm a little worried that I'll get this mixed up. I want to save this change due for later. I'm going to create a variable called so this way I won't overwrite this variable, and I can still call it and figure out how much was due in the beginning anyway. So now I've got this working variable. I'll say if $1 is less than or equal to working left, then I'm going to come in here I'm going to create this. Dollar count equals 0. And so I'll say dollar count plus equals 1. And so this is incrementing how many dollars that I'm going to have. So I'll run this. I don't think it's, yeah, change back is 400. We haven't got very far yet. I'm going to say that worst case scenario, it would have been really nice to drop this in a loop, but we haven't quite covered the loops yet. So I can stack this. Oh, we should also say, okay, so if we've incremented the dollar count by 1, we should also say working change left is now equal to, well, we can just do minus equals 100. And we'll do printf, print give back and so we run this. I got my syntax wrong. I had a typo. Yay, there we go. All right. So let's say that our worst case scenario, $5, right? So let's just go ahead and set this at the worst possible amount of change that we're willing to consider. Okay, well, if we owe $5 back, then we can just run this code 5 times. Nope, gonna have to do better than that. Let's see if that runs twice now. So $4, $3. And so we can copy this. So this is counting down nicely, but we still have $1 to give back. So I will come and grab this. All right, so we save that. And so we do get down to 0 with this worst case scenario. And then I'm going to do something. And I'm going to come down to the end. It says, write a program, the total change amount as an integer input, output the change using the fewest coins. A coin twice. So there is a silver, there is the dollar coin. So they used to have the Sacagawea dollars. They also have the silver dollars. Okay. So we'll come down here now and we'll say, we'll have a different section. I'm going to call this section print off results. And I'm going to say if so I'm going to say if 0 equals or is the same thing as dollar count. Oops. Then says US coins. So it looks like we don't need to have the $0 count case because in the example, it just skips right over it. So I'll say if dollar count is 1, then I'll say print and this will be $1, because that should be singular. And now I'll link this elif 1 is less than $count. Then I want you to print. This time I'm going to use the formatted print. And the reason I want to do that is I want to do dollars. Okay, so let's clear this up. And let's test this. Okay, $5. Good. Test it with 4 just to make sure it works. Yeah, $4. $3. $2. Yeah, $2 works. And let's do it with $1. Make sure that we get the expected. $1 singular. Cool. And now let's make it 70. Let's make it 99 cents. And we notice we don't get $1 if we make it $1.99. So it would be $1. And we don't have the other part taken care of. We'll make this $2.99. Yeah. Okay. Cool. Well, that is we're starting to see a pattern that might work. All right. So we've got change is more than $1, and now we can deal with change less than $1 and more than a quarter. Okay, so the largest coin is going to be $1. Now we're going to work through a quarter. So I'm going to peel this out, this if statement. I'm going to paste it right here. Okay. Now we're not working with the dollar coin anymore. We're working with a quarter. So working change left. And this isn't going to be quarter count or dollar count. This is going to be quarter. Okay. And we'll use the quarter count variable down here. And again, we're not working with a dollar. We're taking off a quarter. Okay, but the problem is so if we said the worst case is $5, this takes care of $1, $2, $3, $4, $5. Now with a quarter, worst case, if we're giving back quarters, not dollars, then that'll be, let's say it's 99 cents. Because if it was more than 99 cents, we just give back another $1. So 74, grab this. Save it and test it. 49, we can still get another quarter out of that. 24, that is less than a quarter. So now we can start getting ready for the next case. If change is less than a quarter, more than a dime. But we also need to go back and we need to test this. So let's steal this little block of code here. And we'll say if quarter count Um, Q. Okay, and now let's test that. So 3/4, and then we'll make this 50. That should do 2/4, do 25, 1/4, good. And let's do 20, should be no quarters. And let's do 4.99, should be 3/4. $4, 3/4. I like it. Okay, we can continue to still the same pattern. And again, the trick on this is you have to split the problem apart and kind of work through it in stages. Well, now we're working with a dime. Well, we need another dime counter. So we'll grab that. Oh, we're taking away dimes, not quarters. All right, so let's run this. 14 cents is what we still need to give back. So we can possibly give back one more dime. So let's add that here. We'll run it. And 4 cents is now less than a dime. So we can come here. Now we can copy this again. And this is going to be dime count. And this will be the word dime. So 2 dimes, like this, 89 cents. So we see it's 1 dime. That makes sense. Now make it 4.79 to test it. And now we see that there's no dimes left. Okay, so nickels. I'm going to grab these 2 lines of these 2 chunks of code because I'm getting what? Maybe excited. So it's less than a dime, more than nickel. And again, we need to come up here. I'm going to do 2 at a time. I'm going to say this is nickel count. And this one is going to be a penny count. So our nickel count will come down here. And we'll use with that. And we're popping off a nickel at a time. And I'm just going to go ahead and get aggressive. Okay. Yep, penny count. And this time we're taking a penny off at a time. We're going to need probably 4 pennies. So there's 2. If we needed 5 pennies, we could have just give it another nickel back, and then it's less than 4 pennies. So we'll come down here. We'll grab our dime count example. Okay, let's clear this up. And um, so we'll start with $5. Okay, I tell you what, um, I think to clear this up, I'm going to get in here and I'm going to tidy up our code just a little bit. And the logic behind this is it was helpful when we were working through this to be able to see what we still needed to go and have lots of these print statements. But the problem is we're just getting so many print statements that it's starting to be a little bit much. I do also want to point out that if you wanted to use a list might have worked well for the nominations. Okay, let's clear this up and let's see what it looks like now. So we go ahead and run it. Change due back is $5. Cool. You still need to give back. That's what we wanted to see. We see exactly $5. So now let's make it $4.99. We should see lots of different coins. All right. So that gets us down to zero. $4, 3/4, 2 dimes, and 4 pennies. Okay, so let's make this 3 pennies less. So we'll make that a 6. Run it. 1 penny. That's what I like to see. So let's make it 2 pennies less now. We should see a nickel. Make it 4. We see 1 nickel. There's no way to get 2 nickels, so we're not going to worry about that. We're also seeing it goes from 2 dimes down to 1 dime, so that's kind of cool. We've got 3/4 right now, so I'm going to make it 50 cents less. And we see we do get down to 1/4, and we're doing $4. So I'm going to make it $3 less, or make it $3. I need to make it $2 less. Okay, now let's start to make some of these disappear. So I'm going to make it 3 pennies less to make it 1 penny again, just to verify that. Oh, my math is not. Just make it uneven. So no pennies. I'll make it 5 cents less. So the nickel should go away as well. And now I'll make it 10 cents less. And we see the dime goes away, make it 25 cents less. We see that the quarter goes away, and let's just test 0. Yay. All right, friends. I'm going to say this is a little bit of an ugly code. It's not a perfect code, but what I do enjoy about it is that we can see very much this is how you use an if statement. We did use some variables. We could make this as an input, and oops, I need to fix my syntax there. And then if you want to make it work with the zybook, of course, get rid of some of the 2 print statements that I was using. Let's test it with the example that they gave us. The example is 45. So we'll punch in 45. Yes, don't forget, if you're going to use input, you need to recast it as a number type before you can do math with it. So let's run it again. And we'll say 45, and it says 1/4, 2 dimes, and that is our expected output and our expected spacing. Okay, so as I try to do with all of these, I'm going to go into GitHub right quick, and I'm just going to tell my and we can open up. So I'll just show you how to do this. It's github.com/swasu, and we have a repository called Swasu Python CS Python examples. Click on CS1, come here to chapter 4, and we can see Cashier Algorithm. And hopefully this looks very familiar because this is the code that we just wrote. So you can get in here, you can play with it. There's a lot more efficient ways to do this, but this is one way to get started. Also, this works well for the small coins, but it's something to get you started. It's a way of thinking about an algorithm. All right, friends, I appreciate your time. I hope everyone is doing well. And remember, if you have any questions, please do try to email me. Thank you and take care.